Next problem. A WSS random process x of t with a autocorrelation function A.C.F Rxx of tau which is equal to a e power minus alpha modulus tau, where a and alpha are real positive constants, is applied to the input of an linear time invariant system with impulse response h of t which is equal to e power minus bt u of t, where b is a real positive constant. Find the autocorrelation function of the output y of t of the system. Given Rxx of tau which is equal to a e power minus alpha modulus tau, equation number 1. Given the impulse response h of t is equal to e power minus bt u of t. We know that u of t which is equal to 1 t greater than or equal to 0, 0 t less than 0. So applying to h of t, you will get h of t which is equal to e power minus bt. Instead of u of t, you are putting 1 when t greater than or equal to 0, 0 t less than 0. That is equation number 2. We know S xx of omega which is equal to Fourier transform of Rxx of tau which is equal to Fourier transform of a e power minus alpha modulus tau. So a is a constant, we are taking it outside a Fourier transform of e power minus alpha modulus tau. Applying Fourier transform definition, a into integral minus infinite to plus infinite e power minus alpha modulus tau e power minus I omega tau d tau. So we are splitting into two parts, negative part and positive part. A into minus infinite to 0, negative part e power minus alpha. In negative part, modulus tau is nothing but minus tau. So we are replacing that value minus tau e power minus I omega tau d tau plus a into positive part 0 to infinite, integral 0 to infinite e power minus alpha. In positive part, modulus tau is nothing but tau into e power minus I omega tau d tau. Right? That is equal to a into minus integral to 0 e power, tau is common, take it outside, alpha minus I omega into d tau plus a into integral 0 to infinite minus tau is common, e power minus tau e alpha plus I omega d tau. So we know the integral value of e power ax is equal to e power ax by a, right? That is capital A into e power tau alpha minus I omega by alpha minus I omega, lower limit minus infinite, upper limit 0 plus a into e power minus tau alpha plus I omega by minus alpha I omega, lower limit 0, upper limit infinite. Applying lower and upper limit for the both the terms, so you will get a e power 0 by alpha minus I omega minus e power minus infinite alpha minus I omega minus a into e power minus infinite alpha plus I omega minus e power 0 alpha plus I omega, right? That is equal to a into 1 by alpha minus I omega 0 minus a 0 minus 1 by alpha plus I omega. A is common, take it outside, you will get 1 by alpha minus I omega plus 1 by alpha plus I omega. Taking LCM, so alpha minus I omega, alpha plus I omega. So adding both the terms alpha plus I omega plus alpha minus I omega in the numerator, you will get 2 alpha divided by, again you are using a square minus b square formula. A is nothing but alpha, b is nothing but I omega. So alpha square minus I omega square, I square minus 1 minus into minus plus, you will get plus omega square, right? So yes, xx of omega which is equal to a into 2 alpha by alpha square plus omega square, equation number 3. Now to find modulus h omega square. H omega square we know h into h conjugate, right? H star, that is equation number 4. We know that h omega which is nothing but Fourier transform of impulse output h of t which is equal to minus infinite to plus infinite h of t e power minus I omega t dt which is equal to, we are splitting into two, negative part and positive part, minus integral minus infinite to 0, 0, because in the negative part h of t is 0, right? From 2, equation number 2, 0 into dt plus integral 0 to infinite e power minus bt. In the positive part it is e power minus bt into e power minus I omega t, which is equal to integral 0 to infinite e power minus I omega t into dt, which is equal to 1 by minus b plus I omega e power minus b plus I omega t integral limit 0 to infinite. because e power ax we know e power minus ax integral e power minus ax which is equal to e power minus ax by minus a. Instead of a you are having b plus I omega, that is what. So applying the upper and lower limit, e power minus infinite 0, e power minus 0 1. So you will get minus into minus plus, so you will get 1 by b plus I omega. So multiplying numerator and denominator by the conjugate of the denominator b minus I omega into, so you will get b minus I omega in the numerator. So in the denominator b plus I omega into b minus I omega, a plus b into a minus b, again you will get b square plus omega square. Therefore h of omega is equal to b minus I omega by b square plus omega square. Its conjugate b plus I omega by b square plus omega square. Therefore modulus h omega square, which is equal to multiplying h and h star conjugate, you will get numerator b minus b I omega b plus I omega, a square minus b square, you will get b square plus omega square. In denominator b square plus omega square 2 times, so it will become b square plus omega square the whole square. So cancelling 1, so you will get 1 by b square plus omega square, that is equation number 5. We know that s yy of omega, which is equal to modulus h omega square s xx of omega. So substituting all the values, 1 by b square plus omega square into s xx of omega, which is equal to 2 alpha a by alpha square omega square, by using equation 3 and 5. So s yy of omega, which is equal to 2 alpha a b square omega square alpha square omega square, that is equation number 6. Consider 1 by b square plus omega square into alpha square omega square. Now we are using partial fraction method, right? So b by b square plus omega square plus c by the second factor alpha square plus omega square. Now we need to find the value of b and c. So multiplying in the taking LCM, so 1 by b square plus omega square into alpha square plus omega square, cross multiplication. So b into alpha square omega square plus c into b square omega square by b square omega square into alpha square omega square. Equating numerators, right? Because denominator equal, therefore equating the numerator, 1 is equal to b into alpha square omega square plus c into b square omega square. So grouping, so omega square term in the first bracket alpha square plus omega square into b, so b omega square, second bracket c omega square. So grouping omega square b plus c into omega square. The first term b alpha square, the second term c b square, that is the constant term, right? So equating the coefficients on both sides, b plus c equal to 0 and b alpha square plus c b square is equal to 1, 8 and 9. So we are going to solve 8 and 9. So 6 implies b equal to, 8 implies b equal to minus c. So using in 9. So 9, so minus c alpha square, instead of b you are putting c, minus c alpha square plus c b square equal to 1. Therefore c is equal to 1 by b square minus a square. Therefore b is equal to minus c, minus 1 by b square minus a square. So 6 and 7 implies syy of omega, which is equal to 2 alpha a b square omega square into alpha square omega square, which is equal to 2 alpha a. So we b by b square omega square, instead of b we are putting the value 1 by b square minus a square by b square plus omega square. Second one plus c by, so instead of c we are putting 1 by b square minus a square, alpha square by alpha square plus omega square. Syy of omega, which is equal to 2 alpha a by b square minus omega alpha square. So minus 1 by b square plus omega square plus 1 by alpha square omega square. So right, so syy of omega is nothing but syy of omega is nothing but Fourier transform of ryy of tau, which is equal to right hand side, same 2 alpha a by b square minus a square minus 1 by b square omega square plus 1 by alpha square plus omega square. Taking inverse Fourier transformation, so right hand side f inverse of f ryy of tau becomes ryy of tau. In the left hand side, 2 alpha a by b square minus a square constant, take it outside from the inverse Fourier transform, f inverse of minus 1 by b square omega square plus 1 by alpha square plus omega square. So separating two terms, taking inverse Fourier transform to each terms f inverse of minus 1 by b square omega square plus f inverse of 1 by alpha square omega square. That is equal to 2 alpha a by b square minus alpha square 1 by 2 pi integral minus infinite to plus infinite e power minus I omega tau by b square omega square d tau plus 1 by 2 pi integral minus infinite to plus infinite e power I omega tau by alpha square plus omega square d tau. Applying inverse Fourier transform definition right here. 2 alpha a by b square minus a square. So you will get minus pi by 2 pi b e power minus b modulus tau plus pi by 2 pi a e power minus pi by 2 pi alpha e power minus alpha modulus tau. Since we know the formula, integral minus infinite to plus infinite e power I omega tau by omega square plus alpha square d omega, which is equal to pi by alpha e power minus alpha modulus tau. Therefore Ryy of tau, which is equal to 2 alpha a by b square a square into minus e p minus b modulus tau by 2b plus e power minus alpha modulus tau by 2e. Thanks. We'll see in the next video.